So hi, in this video, we will be discussing the integration formula for exponential functions. Okay, so all we have to remember are these two very simple formulas. So you have the integral of e to the u du is equal to e to the u plus c. And the integral of a to the u du is equal to a to the u over ln of a plus c, where a is greater than 0. Okay, so let us review exponential functions. So it is classified as an exponential function if the exponents are variables. Okay, and then we have the base here are constants. Okay, so e, that is the natural number. Okay, so it has a value of 2 point something, so it's in your calculator actually. So where's e? Alpha e. Okay, so its value is 2.18718 blah blah blah. Okay, and then a, okay, is any constant as long as a is greater than 0. Okay, because in the formula, as you can see, we have ln of a, okay, for which there is no natural logarithm for a negative number. So say for example -1. So you try to input that in your calculator, natural logarithm of -1, so it will say math error. Okay, so yeah, so these two formulas are all we need. Just make sure that the differential part is the complete differential of u. Okay, so say for example, so we have the integral of y e raised to negative y squared. Okay, so obviously our u here will be the exponent of e. So our u here is negative y squared. Okay, so its du, complete differential, is negative 2y dy. Okay, so as you can see, if we rearrange this, so transferring y beside dy, so it will become integral of e to the negative y squared times y dy. Okay, so as you can see, the complete differential should be negative 2y dy. So therefore, we must multiply this by negative 2, and then to balance that out outside the integral sign, so we write the reciprocal of negative 2. So this will become integral of e raised to negative y squared, and then multiplying negative 2, so negative 2y dy. Okay, so in that case, since we multiplied negative 2 inside, so outside we will also multiply it by the reciprocal of negative 2, okay, which is negative 1/2. Okay, so we can now apply the formula. So all we need to do is copy e to the u, so this will become negative 1/2, and then the integral of this is e to the negative y squared, okay, plus c. So this is now our integral. Okay, so it's that simple. All we need to do is apply that formula. So another example, so we have here the integral of e to the 2t dt all over 1 plus 6e to the negative 6e to the power of 2t plus 9e to the power of 4t. Okay, so in this case, this is actually just general power formula and not using this formula here. So as you can see, the denominator is a perfect square trinomial that we can factor. So we can express that as in the numerator e to the 2t dt. So we can factor the denominator as 1 plus 3e raised to 2t squared. Okay, or we can express that as the integral of 1 plus 3e raised to 2t raised to negative 2 times e raised to 2t dt. Okay, So using our power formula, our u here is 1 plus 3 e to the power of 2t. Okay, so our du therefore must be equal to, so we have 0 for the derivative or differential of the constant, plus 3 times the differential of e raised to 2t is copy e raised to 2t multiplied by the differential of the numerator 2 dt. Okay, so its complete differential must be 6 e to the 2t dt. Okay, so in this case, as we can see, our differential part is it lacks a coefficient of 6, so therefore we must multiply that by 6, so is equal to 1 plus copy e to the 3e to the 2t raised to negative 2 times, so complete differential should be 6e to the power of 2t dt. Okay, so since we multiply 6 there, so outside the integral sign we must multiply the reciprocal of 6, which is 1/6. So therefore we can now apply the general power formula. So copying 1 over 6 times u raised to n plus 1, so we have 1 plus 3e to the power of 2t raised to negative 2 plus 1 over negative 2 plus 1. So simplifying that, so it will become negative 1 over 6, and then this will become 1 plus 3e to the 2t raised to negative 1, so therefore it will become negative 1 over 6 times 1 plus 3e to the power of 2t, and then plus c. Okay, so this is now our answer. Okay, so for our last example, so we have integral of 10 raised to negative 3x dx. So our base is not e anymore, so we can use this formula where a is any constant greater than 0. So our a here is equal to 10. Our u is equal to negative 3x. So therefore our du must be negative 3 dx. Okay, so rewriting this, so this will become integral of 10 raised to negative 3x. The differential part must be negative 3 dx. Okay, so since we multiply negative 3 in here, so outside we must multiply negative 1/3. Okay, or the reciprocal of negative 3. So that is equal to negative 1/3. Then the integral of this now is equal to this. So copy a to the u. So times 10 raised to negative 3x over ln of 10 plus c. Or we can simplify this as negative 10 raised to negative 3x over 3 ln of 10 plus c. Okay, so that's it. So it's a very simple formula. Actually, it's one of the simplest integration formulas. Okay, so that's it. Thank you for watching.